All right, so I have exactly about 5 minutes before my students come back from lunch, and I have to explain to you some basic trigonometric functions. So for my geometry class that I'm going to have in a minute, I just want to let you know how to use these functions. So first, we have my best friend over here. Okay, he's not really my best friend, but we have this friend of mine. His name is theta. All right, that's theta. He's right there. Theta represents an unknown angle, just like a variable represents an unknown value. All right, theta represents an unknown angle, and usually, well, in this case, we're going to be talking about right triangles. Okay, so my friend theta, okay, he lives right here. He likes to be in the corner. Okay, and this is his house. Now, the longest side of his house has a special name. We call it the hypotenuse. My geometry students like to call this guy, big-headed looking guy Thanos, so he's hypotenuse. All right, we'll discuss that later. Anyway, the other sides of the triangle, they're always named based on how far away from theta they are. So right here, this side is the adjacent wall. Adjacent. I think that's how you spell adjacent in this 5 minutes that I'm kind of improving this. And this is the opposite wall. Opposite, opposite. All right, so this is the opposite wall and this is the adjacent wall. And that's important. It doesn't matter what orientation the triangle is, as long as you can find the hypotenuse or the hypotenuse, all right? And you place theta in one of these corners, okay? One of these angles, okay? Then you're gonna have the adjacent side, which is right next to, and it's like adjective, adjacent side right here next to theta. And the opposite side is always gonna be the side that doesn't touch theta. So this is the opposite side up here, and this is the adjacent side here, and that's right here. We can put theta in, let's put theta right here. We'll put theta down here, okay? I'm drawing a little theta man. All right, so this is the opposite side, and the adjacent side that touches him. All right, so that'll be something to practice. Now, the other thing to practice is, well, what if I want to figure out what one of the missing sides is? We have a formula. We got the Pythagorean theorem, right? A squared plus b squared equals c squared. Everybody knows the Pythagorean theorem, okay? Pythagorean theorem. But that only works if you know 2 of your 3 sides. So what if I have a triangle where I don't have 2 of the 3 sides? Instead I have, let's go with a white triangle. Let's say instead I know one of the angles. We'll probably have to erase that. But I know one of the angles, so let's say we know theta, all right? I like my friend theta. And let's pick another side. We're gonna pick this side to be 15. Okay, so we know what theta is. Oh no, theta is yellow. It's fine, theta can be yellow. So we know what theta is, and we know one of the sides. So now we're gonna use a trigonometric ratio. So we have 3 of them. We have sine of theta, and sine is gonna be the opposite side divided by the hypotenuse. It's a ratio. So the opposite side divided by the hypotenuse. It's gonna cosine of theta. That's a ratio of the adjacent side over the hypotenuse. And then you have tangent. Now tangent is going to be, sine divided by cosine, or in other words, the opposite side divided by the adjacent. And we'll break all of these down later, but for right now, just like the Pythagorean theorem, sometimes we dive into using the formula, and then we kind of backtrack into where did this come from. Again, I only have 5 minutes. So, here's how you use these formulas. Just like with the Pythagorean theorem, if I knew 2 of the sides, I'd plug those sides into the respective places. C represents the hypotenuse. In this case, I need to find which one of these. So we know that the long side right here, so this is my right angle, and this is the triangle that I accidentally made. But this right here is my right angle, theta's right here. My long side right here, which is opposite of my 90-degree angle, that's 15. So I know, that's the hypotenuse. The opposite side is right over here, and the adjacent side is right here. So let's figure out what the opposite side is. The opposite side is going to be the sine of theta. That's opposite over hypotenuse. All right, so the hypotenuse is 15, so sine And let's give theta a number. Usually in these problems, you would know exactly what theta is. So we're going to give theta the number of 30 degrees. Okay? So the sine of 30 degrees, the opposite side we don't know, and the hypotenuse is 15. Okay? In order to solve this, because this is a fraction, we can just multiply both sides by 15. So we're going to multiply both of these sides by 15, and that will solve my equation. So I got 15 times sine of 30 equals the opposite side. So that means whatever number you get when you plug this in the calculator should be your answer for the opposite side. And then you would do the same thing with these other ones. So let's see what we got, and that's all I got time for right this minute. Maybe I'll get another video in soon. So here is, that's all I got. It's all right. They're knocking at my door. Ah!